All right, guys, today we're going to talk about linear inequalities and how to graph them. It's very similar to graphing lines, so if you already know how to graph lines, then this should be a pretty smooth process for you. But if you're not sure how to graph lines, then this might be a little bit more challenging. So first thing, when we solve a regular equation, we're just trying to isolate a variable. So in this case, I would subtract 5 and then divide by 2. We did that at the very beginning of the year. And then we did solve inequalities also. So if I do the same thing here, I'm just going to have, instead of equal, a greater than sign. All right, so we have already solved both of those kinds. We even graphed these on a number line. But what we're going to do next is talk about how to graph them. So graphing a line in itself, you should already know how to do. In this case, my intercept is 3, so that's where I'm going to start. And then my slope is 1/2, so I'm going to go up 1, right 2. Up 1, right 2. Then you connect your points, and you should have arrows on the end because lines go on forever. And inequality is going to start the exact same way. But then, from there, we're going to shade one side of it because when we're graphing a line, all of our solutions, everything that would work for this equation is a point on this line. But here, we have every point on this line and everything bigger than that because we have a greater than sign. So we're going to shade in everything above our line as well. So everything in this range, including points on the line, are solutions to this inequality. They would all work. So here it says solutions to a linear equation are ordered pairs on the line. Solutions to a linear inequality are all the ordered pairs in the shaded region, which is what we just talked about. So the difference between dashed or solid lines. Up here I used a solid line because I have an or equal to. So dashed lines are going to be your regular less than and greater than, and solid lines are going to be when they have the or equal to portion of the symbol. All right, so if you have a dashed line that does not include points on the line, just points above or below the line. You can check your shading by plugging in a point. So like let's say I want to check and make sure I shaded this correctly, and I want to plug in the point 0.04. I had y is greater than or equal to 1/2 x plus 3. So I'm going to plug in 4 for y and 0 for x. And I get 4 is greater than or equal to 3. That is true, so I shaded the right region. If I got something that was not true, then that means I need to erase this and shade below. But since it's true, I did it correctly. The last thing we need to remember is that we have to reverse the direction of the sign when you multiply or divide both sides by a negative. So that's something we again talked about at the beginning of the year, but you need to remember to do that when you are graphing these. All right, the other side of your page. So step 1, solve the inequality for y. We always want to isolate y when we're graphing because it helps us, first of all, graph the line with our slope and intercept, but second of all, that's also necessary for us to know where to shade. Then we want to pay attention if we need a solid line or a dashed line, depending on our symbol. And then lastly, we'll shade the correct side. So here, y is greater than or equal to negative 2x plus 1. I'm going to start at 1 and then go down to right 1 for my slope. This is going to be a solid line because it has the or equal to underneath. And then greater than, y is greater than, I need to shade where my y's are all bigger than my line, which would be this side. And again, you can check by plugging in a point if you need to. Okay, this whole side. Okay, this next example, I need to isolate y first. So I'm going to subtract 2x from both sides. And then everything gets divided by negative 3. which means I'm going to flip my sign. So now I have y is greater than, or I'm sorry, it was greater than, now it's a less than 2/3 x minus 3. So I'm going to start at -3, then up 2/3. This would be a dashed line because it does not have the or equal to. And then y is less than that, so I want to shade everything below my line. So this would be our final answer. Can you list 2 possible solutions from the graph? Let's say we're going to be talking about, let's talk about this one. So we need to pick one to use. Can I list 2 possible solutions? So that could be anything from this section. So let's say 5, 0. That for sure be one. Also 3, -3, let's say. But there's tons we could choose from. Anything in this region. Is -1, 1 a solution? That would be right here. We would say no, because it's not in our shaded region. Okay. Y is greater than or equal to 3 is a horizontal line, because if we go to our y-axis and put a point on 3, we need our line to cut through there. A horizontal line has a slope of 0. So this would be a dashed line because it does not have the or equal to. And then it says that y is bigger than that. So we need to shade above. X is greater than or equal to -5. So on my x-axis at -5, I need a line going through that. This one would be solid because it has the or equal to. And then it says x would be larger than that, so I'm going to shade to the right. All right, last thing we're going to talk about is how to do the opposite, essentially. How to take a picture and write our equation. So for this one, my b is 5, and my slope looks like it's up 1/1. So slope of 1/1 is the same as 1, and my intercept is 5. So I have y is equal to, I'm not going to put a sign yet actually, 1x plus 5. You don't have to write the 1, but you can. And then my y's are all above this line, so I need y to be greater than or equal to because it's a solid line. Okay? At this point, you can ask the sub for the 5.6 worksheet. Just raise your hand and show them your notes.